Hey there, space enthusiasts! Get ready to blast off into the cosmos with us. Welcome to Spaceverse, where the universe is our playground and curiosity knows no bounds. Join us on an interstellar adventure as we dive into the depths of space, uncovering its mysteries and marvels. From the secrets of black holes to the landscapes of alien worlds, we're here to ignite your imagination and expand your cosmic horizons. With mind-blowing visuals, expert insights, and the thrill of exploration, Spaceverse is your ticket to the ultimate cosmic journey. So strap in, hit that subscribe button, and let's embark on an epic voyage together into the vast unknown of Spaceverse. What really differentiates SpaceX from those around it in the aerospace industry is the company's willingness to come up with ideas that are so outlandish that they are hard to put into practice. In the event that there is one more factor that differentiates SpaceX from its rivals, it is the company's ability to transform ambitious ideas into practical applications. Additionally, this innovation is shown by the Raptor engine that is found aboard the Starship. It is not simply another rocket engine. Rather, the Raptor is a redesigned version of the rocket engine. Let's go back to the beginning with SpaceX's Merlin rocket engine, which was the company's first rocket engine to be manufactured. Throughout the course of SpaceX's ongoing testing of their initial Falcon 1 rocket, we saw several iterations of the Merlin design. One of the first 5 flights of the Falcon 9 was powered by the Merlin 1 Coulomb engine, which was also the engine that was responsible for the first successful launch of the Falcon 1. At this point, the Merlin 1D engine is being used to propel each and every one of SpaceX's Falcon 9 and Falcon Heavy rockets. The design of the Merlin engine was influenced by the chaotic circumstances that prevailed during the early days of SpaceX's existence. When the year 2000 rolled around, it was an extremely rare occurrence for a private technology company based in California to get engaged in the field of orbital rocket launch. Because they did not believe that the endeavor would be successful, no one was ready to invest any money in it. SpaceX was squandering its cash reserves at the same rate that they were wasting their rocket fuel, yet the whole operation was being supported by Elon Musk's immense riches from PayPal. Elon Musk's stated objective with the Merlin was to build a rocket engine that was not just straightforward but also economical. The question then is, how does it look? Let's briefly go over the fundamentals of how a rocket engine works so that we can both understand it better. Getting your mind around the core concept that is being discussed here won't be that difficult for you. One propellant tank is used for fuel, while the other is used for oxygen. Both of these propellant tanks are located inside the main body of a rocket. Due to the fact that all rockets need oxygen for burning, the oxygen side functions in every rocket. To put it another way, it is almost the same as adding more air to a wildfire in order to make it burn hotter. In order to transform oxygen into rocket fuel, the first step is to compress it into a liquid state. The transformation of oxygen from a gas into a liquid may be accomplished by supercooling it to a cryogenic temperature. At temperatures lower than its boiling point, which is -183 degrees Celsius or -297 degrees Fahrenheit, oxygen will continue to exist in the liquid state. RP1, which is effectively refined kerosene, is included in the Merlin's fuel system. This chemical is used to power the engine. It may be obtained easily and at a low cost, and it is a liquid that is at room temperature. At the beginning of the rocket engine, 2 pumps will propel highly pressured oxygen and fuel into the combustion chamber. Once there, the 2 substances will be combined and then lit fire. A significant amount of energy is released as a result of the propellant's combustion and expansion, which results in the production of an enormous amount of pressure. The whole amount of energy that is contained inside the combustion chamber will be discharged via the throat. The process of exhaling air from your lungs via a small opening in your lips is comparable to blowing out a candle during the process of exhaling. You increase the pressure in your mouth cavity to a high level, which causes the gas to be expelled via a very small opening. The exhaust that is produced by the combustion process, which is both hot and pressurized, then increases in size as it travels from the throat to the nozzle aperture over time. As it exits the throat, the exhaust is already moving at a high speed. This expansion just makes it go even faster than it was before. The expansion ratio between the throat and the nozzle's termination represents the proportionate relationship between the acceleration of the exhaust and the expansion ratio. While following this process, force is converted into forward motion. It is possible that the rocket will accelerate more quickly if we are able to blast the exhaust gas from the back of the nozzle as quickly as possible. It is possible to find a reaction to any action. The 2 fuel and oxygen pumps used in the Merlin engine are powered by a component that is referred to as a gas generator. This little rocket engine discharges directly into a turbine, making it similar to a miniature rocket engine with its own combustion chamber and nozzle. Instead of pointing downward, it discharges directly into the turbine. Now the major fuel and oxygen pumps are driven by a turbine that is linked to a main shaft. This main shaft is being spun by the pressure that is generated by the combustion process. After the turbine has been spun up, the gas is expelled from the side of the engine in addition to the exhaust pipe. This idea, which goes back to 1944 and the German V-2 rocket, which was the first ever long-range ballistic missile, is what we refer to as an open-cycle gas generator. In answer to Elon's request, he was satisfied with the simplest and most cost-effective rocket engine that could possibly be imagined. SpaceX's Merlin engine continues to be an outstanding product even to this day, and it is quite probable that it will continue to be so for the long term as well. However, in order to construct the next generation of SpaceX spacecraft, it was going to be required to design new engines for SpaceX. Elon Musk provided his engineers with a new set of objectives while he was developing the Starship. These objectives included the creation of a rocket engine that had the highest thrust-to-weight ratio of any engine that is presently in use, and the use of an entirely new kind of rocket fuel to power the engine. It was thus evident that the use of tried-and-true styles from the 20th century was not an option given the circumstances. Perhaps now is the time to start reimagining the rocket engine. This is where we can start talking about the unconventional fuel source. Kerosene has been replaced with methane as the fuel of choice for the Raptor. Although it is worth the added complexity, the process of liquefying methane at a cryogenic temperature is similar to that of liquefying oxygen, which makes it a great rocket fuel. This is because methane can be broken down into smaller molecules. Due to the fact that kerosene is a long-chain hydrocarbon, it is very difficult to totally burn it and turn it into gas. A significant quantity of solid materials will be left behind as a result of the combustion process. Even in a controlled environment, such as the combustion chamber of a rocket, the leftover carbon solid is the same as what you would find inside a chimney, a dark dust that is often referred to as soot. Coking, which refers to the deposition of soot on the inside of a rocket engine, is an issue that affects many rocket engines. On the other hand, this is not often a problem since the majority of rocket engines sink to the ocean bottom after just one occasion of use. Elon has high aspirations for the period within which Starship will be able to reuse its engines. Nevertheless, a reusable engine like as the Merlin needs extensive cleaning between launches, which is not going to work. It is his desire that they go live many times per day. As a result of the fact that methane is mostly composed of hydrogen and includes just one carbon atom for every 4 hydrogen atoms, it is quite easy to totally burn the carbon without releasing any additional byproducts. Because natural gas is a gas that is already present in your home, you may burn it in your stove or furnace for the whole day without having to worry about leaving behind any carbon residue. Natural gas is almost entirely composed of methane. Moreover, it is energy. From this perspective, how does the inner workings of the Raptor engine compare to those of the Merlin that came before it? The design of the Raptor, which is referred to as a full-flow stage combustion cycle, is comprised of an extremely complex network of pipelines, turbines, and pumps. The engine schematic should be returned to. In the Raptor cycle, the liquids are transported from the tanks to the main pumps, and then, as the last step, they are sent to the gas generators. Both the gasoline and the oxygen were powering their own individual turbines. As contrast to the 1 or 2 turbines that were used by prior versions, which were either oxygen or fuel side reliant, the Raptor is one of a kind among engines since it is equipped with 2 gas turbines. As opposed to everything rotating on a single main shaft, we now have independent turbines and pumps for each and every tank. The cryogenic liquid must first overcome a pre-burner in order to get to these turbines. This is the first hurdle that it must overcome. A pre-burner is used by a miniature rocket engine such that in order to transform liquid fuel into petrol. On the other hand, since oxygen and methane cannot burn on their own, a cross-connection between the 2 pre-burners is necessary. This is done so that a tiny quantity of oxygen may join the flow of methane, and a small amount of methane can join the flow of oxygen. The exhaust gas that is forced into the turbine after combustion has taken place is what causes the blade of the turbine to spin. At the same time as the turbine blade is turning the pump, our propellants, which are now gaseous, are transferred into the combustion chamber under a huge amount of pressure. In the event where the turbine is the one responsible for spinning the pump and the pump is the one responsible for supplying liquid to the turbine, or it is the first step in the process. At the launch mount, SpaceX installs the gear that is responsible for spinning the turbines that are located outside. Because of this, the Starship launch mount serves as the equivalent of the main rocket's starting point. Having it is absolutely necessary in order for the booster to be lit. Two important things to bear in mind are: the most significant disadvantage of this design is that it does not need an exhaust pipe to be installed after the turbine. When compared to the open-cycle Merlin, the Raptor is said to have a closed cycle. This is because of the reason stated above. Because the Raptor system includes both gas producers and maintains their pressure inside itself, this activity is carried out at a very high volume of pressure. Before their demonstration of methane's superiority as a fuel source that burns cleanly is provided by the fact that the exhaust from the preburner is not being vented. In the event that this were attempted using kerosene fuel, the system would quickly become obsolete due to the fast buildup of soot inside it. For the second time, the oxygen pump and the fuel pump are not directly linked to the combustion chamber. The oxygen and the methane must first pass through a preburner before they are allowed to enter the chamber. Full-flow stage combustion is the name given to the Raptor cycle as a result of this. When the oxygen and methane reach the combustion chamber, they will react with one another to produce the most efficient combustion that is even remotely possible. The oxygen and methane are now exiting the turbines as gases that are very hot and under pressure. The energy that is produced by collisions between gases will be far more than the energy that is produced by collisions between liquids. Almost 99% is the utmost efficiency that can be achieved with this procedure, as stated by Elon Musk. This is the greatest efficiency that physics can allow for. Elon claims that when it comes to the proper mixing of molecules, the Raptor combustion chamber is not much superior than God himself. Do you realize how complicated it is? As Elon describes it, the ignition mechanism of the Raptor engine is similar to a dance that takes place between the oxygen and fuel systems. Everyone has an effect on everyone else. This is true for each and every one of us. When the oxygen and methane cycles are even slightly out of phase with each other, or if anything else goes wrong, the whole engine will either melt or explode. This is the case regardless of the circumstances. At this point, we have a better understanding of the Raptor's function. The power and performance of the engine are affected by this. What does it imply? We should talk about it. Despite its little size, the engine of the Raptor is capable of producing a tremendous amount of thrust. As of right now, the Raptor version 2 is capable of generate thrust that is equivalent to 230 metric tons at sea level. The power of this rocket engine is unmatched by any other rocket engine on the market. That accolade is well deserved by the F1 engine of the Saturn V rocket. In addition to having a gigantic engine that could accommodate a Jeep inside of it, it was outfitted with twice as much thrust as a Raptor. On the other hand, the Raptor is a very little aircraft measuring just 3 meters in height and 1.5 meters in width at the nozzle. With this, the booster with a diameter of 9 meters is able to hold 33 of them. A similar engine, such as the RS-25 engines that were used by the Space Shuttle and upgraded for the SLS moon rocket, is far larger than the Raptor engine, which is significantly smaller. In contrast to the RS-25, which can only produce around 199 metric tons of force, the Raptor has a power-to-weight ratio that is unmatched with any other aircraft. The Raptor weighs around 1,600 kilograms, which is much less than the RS-25, which weighs close to 3,200 kilograms. The Raptor rocket engine is able to do this by running its combustion chamber at a pressure that is higher than any other pressure that exists elsewhere on the Earth. At the moment, the chamber pressure of the Raptor 2 is 300 bar, which is equivalent to about 4,351 pounds per square inch. For the purpose of providing you with some context, the chamber pressure of an older Merlin engine was around 100 bars lower. Remember that raising the pressure allows the rocket engine to create more thrust via the nozzle and throat. This is something you should keep in mind. As Elon Musk moves on with the design of the Raptor, he feels that the primary emphasis will be on simplifying the engine in order to make it more affordable and easier to produce. The remark "the best part is no part," which is a favorite of Elon's and is at the core of his basic ideals, is brought up here. It is a philosophical theory. Elon, in his capacity as a designer, starts by finding ways to make the requirements and constraints less absurd. This implies that he does not adhere to any regulation that is illogical. During the second stage, any unnecessary actions that were included in the specification phase will be eliminated. It is obvious that you did not delete enough data if you are unable to recover at least 10% of what you deleted. Third, make adjustments. In the fourth place, quicken your speed. In the fifth phase, you will automate. It is quite evident that this occurred during the transition from Raptor 1 to Raptor 2. This new engine has a great deal less components that are visible. Elon claims that he has the intention of removing all of the components that are cumbersome from the engine. It is necessary to replace bolted flanges and solid welds with integrated pipes and wires that are incorporated into larger conduits in order to accomplish this. According to Elon, the shrouds, which prevent heat from entering the engine and act as a protective cover, might be removed if new engine components were included. The design of a rocket ship that gets rid of any characteristics that aren't required would naturally result in a rocket that is much lighter and more affordable. These are two aspects that are essential for the long-term sustainability of space travel technology. The overarching goal, which will be accomplished with the assistance of this approach, is to make Raptor more accessible and less expensive to manufacture. If the rocket can be reused as many times as it needs to, you could ask why there are so many engines. Our focus must be on the future. That's the view from Elon's perspective. He plans to eventually have a fleet of 1,000 Starships or more, and for these rockets to be as prevalent as jetliners are now. The continuous functioning of these spacecraft would allow them to travel between Earth and Mars, the Moon, and even between points on Earth. The Starship's ultimate goal is to become one of the most monumental vehicles ever built by humans. In terms of significance, this ranks with the first transoceanic sailing ships. Interstellar travel is within the Starship's capabilities. A heartfelt thank you for being here with us today as we come to the end of our journey at Spaceverse. Your support is what drives our investigation of the cosmos. Remember to hit the notification bell and subscribe to our channel so that you can continue to explore with us. See you until the next time we cross paths in the cosmos.